So I would like to, just, I finally found my clip. Um, if I could show you a short, I'm just gonna kind of step through, if I can see this really quickly. Wasn't the greatest view, but right here, I wanted to point out on our stacker mechanism, for example, um, this is the kind of effort we go through. It takes more work to design this kind of stuff, but there's no sliding mechanisms on this stacker going up and down. So all of the motion happens on polyurethane wrapped rollers. And so there's no metal on metal contact either. We're the only company that does it this way. And so as you see this stacker, when it goes up and down, the motions are either on rotating bearings or a polyurethane rolling over a metal surface. So these kinds of mechanisms, we've proven with our slab harvester, they'll wear out, but you want that little roller to wear out, not the steel structure. What's commonly done on other machines is they have a hardened steel bearing rolling over a mild steel structure. So there's no question what's going to wear out. It's the expensive steel structure that you have to replace over time. And we don't do our design in that way. And so we have uh, a lot of engineering thought and effort goes into these mechanisms to design them for high lifetime. Now, you see that scissor going up and down, and all those motions are happening on even in the channels. It's all on polyurethane rollers on the metal structure itself. So we couple this design philosophy of um, no metal on metal. There's one place on metal on our machine, and I hate it. It's on our chop off mechanism, which we will replace at some point in time. It's still a really long life mechanism, but everywhere else, uh, we don't use these rollers on steel on steel rollers, if that makes sense. Not only do we eliminate all steel on steel pin movements with polymer bearings, but we also have all of our rolling surfaces are polyurethane on steel instead of steel on steel. So these design philosophies that we have are stem from the fact that our slab machines see so much more cycle life. If we were to design without doing these practices, they would be terrible maintenance nightmares. And it's kind of our track record is we've really been the only successful automated manufacturer to really be highly successful in automated slab harvesting. We've outsold all the competition many multiple times, and we have hundreds of those slab machines out there, and it's because we kind of attacked the mechanical challenging problems of high cycle wear with the slab machine in ways that no one else does in the industry. So now, when it comes to the roll machine, we've applied that same design methodologies and technologies to the roll machine.
So along those same lines, if it gives you any idea when he's talking about these no metal on metal, especially the rollers on the carriage and the gantry, again, I go back to my machine that I owned back in the day that had metal on metal. The rollers for all the gantry were on metal rollers. That machine only did 800,000 cycles total in its life, and all of those channels were worn out. Well, early on in our slab life, our slab machine life, I I had visited a couple of machines that had more than 800,000 cycles on their stacker, and the paint wasn't even off of the gantry yet. The rollers had not even worn through the paint on it yet. And so you can see the comparison in running a urethane roller on metal over, metal on metal.